All right, let's look at part 2 of our lesson on the beginning of our trig functions. The first thing I want to go over are the actual trig functions. A trig function is a function whose rule is defined by a ratio. A trig ratio compares the lengths of two sides in a triangle. We're going to introduce the Greek letter theta. Okay, theta, if you'll notice right here, is a circle with a line drawn through the center. And it's spelled Theta. We're going to use theta to represent an acute angle inside our right triangle. And we're going to use it to find our trig functions. Okay, now one that you're very familiar with is sine. Okay, sine, if you remember, is the opposite over the hypotenuse. So let's go over here and look at this triangle right here. Here's theta. Now what is directly across from theta is A. The hypotenuse, of course, is C, and B is going to be adjacent to theta. Now, you're probably thinking C is also adjacent to theta, and you're correct, but C has a more important role, and that's the hypotenuse, okay? So again, theta right here is an acute angle in our triangle. Opposite of theta is A, adjacent to theta is B, and our hypotenuse is C. We can also put theta up here and have different measurements, but we're just using this triangle with theta located in this position to find all of our trig functions. Now, to find the sine of theta, remember it has to be opposite over hypotenuse. Opposite of theta is going to be A, hypotenuse is C, so that's going to be A over C. Cosine is adjacent over hypotenuse. So to find adjacent of theta, remember it's going to share that side, so that'll be B over the hypotenuse, which is C. So the cosine is B over C. Tangent of theta is the opposite over the adjacent. So here is theta. Opposite of theta is A. Adjacent to theta is B. So the tangent of theta is A over B. So those are the three functions that you have spent a lot of time with and you know pretty well: sine, cosine, and tangent. Now let's talk about our reciprocal functions, okay? So each one of our functions, sine, cosine, and tangent, also has a reciprocal function. So the reciprocal function of sine is cosecant, okay? It is abbreviated CSC. So if sine is opposite over hypotenuse, cosecant is the reciprocal of that, which would be the hypotenuse over the opposite side. Cosecant is also 1 over the sine. So if the sine is A over C in our triangle here, remember sine is opposite over hypotenuse, then the cosecant would be the hypotenuse over the opposite, which would be C over A. See how we just flip them to go from sine to cosecant? Now the cosine is adjacent over hypotenuse. The reciprocal function for cosine is the secant. The abbreviation for secant is SEC. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over the adjacent. So looking over here, we know the hypotenuse is C, the adjacent is B. So the secant is C over B. See how we took the cosine and flipped it? We found the reciprocal. They're reciprocals of one another. The secant is also 1 over the cosine. And that leads us to our tangent and cotangent. Tangent is opposite over adjacent. So the reciprocal function of tangent is your cotangent, which will be adjacent over opposite. So if our tangent right here is opposite over adjacent, A over B, the cotangent would be adjacent over hypotenuse, B over A. And once again, you'll see that they're reciprocals of one another. So the cotangent has an abbreviation of COT, and it is also 1 over the tangent. Okay, so look over those, commit those to memory. You need to know all of these values. Sine, opposite over hypotenuse. Its reciprocal function, cosecant, hypotenuse over opposite. Cosine, adjacent over hypotenuse. Secant, hypotenuse over adjacent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Okay? learn sine, cosine, and tangent, and if you will memorize which ones are reciprocals, you know you can just flip those and you'll get the correct values. Okay, so let's actually apply this information. Okay, so example number 1, we have find all 6 trig ratios for theta shown in the triangle below. Well, if you look, here's theta. We have an opposite, we have an adjacent, but what are we missing? We're missing a hypotenuse. So if we're missing the hypotenuse, it needs to be found. So luckily, in the previous lesson, we reviewed the Pythagorean theorem. So if you'll notice, 30 and 16, those are my 2 sides, because those are the 2 sides that make the right angle. So those are my legs. So I'm going to do 16 squared plus 30 squared is equal to c squared, because that's what I'm looking for. I'm looking for my hypotenuse, or my c. So we know that 16 times 16 is 256, and then 30 times 30 is 900. Let's add those 2 together. And then we're going to take the square root of both sides, and we'll get c is equal to 34. So that's going to be the length of my hypotenuse. Notice the hypotenuse is larger than my leg, 30, and my other leg, 16. The hypotenuse has got to be the longest side. So going through all of these values, the sine of theta, remember sine is opposite over hypotenuse. So here's my theta. Opposite is 16, hypotenuse is 34. So we have 16 over 34. So now you're probably thinking, should I reduce this? You bet you better. All right, so 2 will go into 16 8 times, and 2 will go into 34 17 times. So the sine of theta is equal to 8/17. Now, the reciprocal of sine is the cosecant. So if sine is 8/17, then cosecant is 17/8. All right, now cosine, here's theta, it's going to be adjacent over hypotenuse. Adjacent to theta is 30 over the hypotenuse, which is 34. So we'll have 30 over 34. And once again, reduce. 2 will go into 30 15 times. 2 will go into 34 17 times. Now the reciprocal of the cosine is the secant. So if cosine is 15/17, the secant is 17/15. Now look at the tangent. Tangent, okay, so here's my theta, is opposite over adjacent. So that's going to be 16 over 30. And again, let's reduce. 2 will go into 16 8 times. 2 will go into 30 15 times. Since cotangent is the reciprocal of tangent, we can flip and make that 15/8. Okay? So those are the values of the 6 trig functions given 2 legs of a triangle. If you're given 2 legs of your right triangle, find the hypotenuse using the Pythagorean theorem. Same applies if you're just given the hypotenuse and a leg. Find the other leg using a Pythagorean theorem, because you need all 3 sides in order to find your sine, cosine, and tangent. If you can find your sine, cosine, and tangent, then the cosecant, secant, and cotangent are just going to be the flipped values of those, the reciprocals. All right, let's look at number 10. Given the ratio for the cosine of theta, find the remaining ratios. So I'm giving you the cosine of theta is 2/3. Okay, I know that cosine is the opposite, adjacent over hypotenuse. All right, so I'm going to make myself a little triangle now. It needs to be a right triangle because we're doing right triangle trig. So here's my right angle, and I'm going to let this equal theta. Okay, so I'm giving cosine of theta is 2/3. I know that cosine is adjacent over hypotenuse. So if this is theta, the adjacent is going to be right here, this side length. So I know that it's equal to 2. And then the hypotenuse, which will be directly across from the right angle, will be right here, and it's going to equal 3. So I have my adjacent, I have my hypotenuse, I've got to find my other leg. So that's where the Pythagorean theorem comes in. A squared plus b squared equals c squared. A squared plus b squared equals c squared. Now let's solve for a by subtracting 4 from both sides. Square root, and we get a is equal to the square root of 5. So that tells me this missing side is the square root of 5. Okay? So once again, we had to use the Pythagorean theorem to find those missing sides. So let's go through our values now. The sine of theta, remember sine is opposite over hypotenuse. So here's theta. Opposite is the square root of 5. Hypotenuse is 3. So we get the square root of 5 over 3. Cosine, we already know what it is. It's 2/3. Okay? Now, tangent, if you remember, is opposite over adjacent. Okay, so here's theta. Opposite is the square root of 5. Adjacent is going to be 2. So we get the square root of 5 over 2. And that's going to be our sine, our cosine, and our tangent. Now, the cosecant is the reciprocal of sine. So it's going to be 3 over the square root of 5. But one thing that we already know is we cannot have this radical in the denominator. So let's multiply by the square root of 5 over the square root of 5. We're going to rationalize the denominator. 3 times the square root of 5 is 3 square roots of 5. The square root of 5 times the square root of 5 is the square root of 25, or 5. Since none of this will reduce or simplify, that's my cosecant. 3 square roots of 5 over 5. Now my cosine is 2/3, so my secant will be the reciprocal of that, which is 3/2. My tangent is the square root of 5 over 2, so the cotangent will be the reciprocal of that, which is 2 over the square root of 5, which creates another problem for us because we can't have a radical in the denominator. So let's rationalize the denominator by multiplying the square root of 5 over the square root of 5. 2 times the square root of 5 is just that. The square root of 5 times the square root of 5 is the square root of 25, which is 5. So we get 2 square roots of 5 over 5. Now, look over all of these problems, pause the video, look through everything, memorize these, commit them to memory, know them by heart, and write down any questions that you might have or anything that you didn't understand that I just went through. And now we're going to do this last section, which is finding the trig ratios of our special angles. Remember the 45, 45, 90? Now, these two sides right here are congruent. Okay, so those are going to be x, x, and x square roots of 2. Now, with our 30, 60, 90, remember across from the 30, that's going to be our smallest side, which is going to be x. 60, being our middle angle, is going to be x square roots of 3, and 90, being our largest angle, is going to be 2x. So those are our special ratios for the 45, 45, 90 and the 30, 60, 90. And we're fixing to use those to find all of our measurements. How exciting is that? Okay, so I'm going to start you off, and then I'm going to tell you to stop and let you finish up a lot of these. So let's find the sine of 45 degrees. Okay, so right here, I got two 45 degrees, so I can just pick one and go with it. So sine, if you remember, is opposite over hypotenuse. Okay, so if I use this one, the opposite is x, the hypotenuse is x square roots of 2. So that's going to be x over x square roots of 2. Well, look at this. How nice is that? So we get 1 over the square root of 2, and then once again, we'll rationalize the denominator. And that'll give us the square root of 2 over 2. Okay, now pause the video and you find the sine of 30 and the sine of 60. Okay, let's see how you did. Remember, sine is opposite over hypotenuse. So the sine of 30 is going to be opposite, which is x, over hypotenuse, which is 2x. So x over 2x. Well, once again, look at those x's canceling out. And that's going to give us 1/2. Now with 60, here's our 60 degrees. Opposite of that is x square roots of 3. And then the hypotenuse, of course, right here, is 2x. Well, once again, our x's will cancel out, giving us the square root of 3 over 2. Now let's look at the cosine of 45 degrees. Well, pick one, it doesn't matter which one. Now cosine is adjacent over hypotenuse. So here's my 45, adjacent is x, hypotenuse is x square roots of 2. So I'm going to have x over x square roots of 2. Well, my x's are going to cancel out to 1's. And once again, I'm going to have 1 over the square root of 2, just like I did with sine. Okay, so I'm going to have to rationalize my denominator, get rid of the radical, and I'm going to get the square root of 2 over 2, just like I did with the sine of 45 degrees. Okay, now pause the video and do cosine of 30 and cosine of 60 degrees. All right, cosine of 30 degrees is equal to adjacent over hypotenuse. So let's go over here to 30 degrees. Here's my 30 degrees. Adjacent is x square roots of 3, and then hypotenuse is 2x. So we're going to have x square roots of 3 over 2x. Well, lovely, lovely, the x's cancel out, and I've got the square root of 3 over 2. Now, my cosine, still looking at adjacent over hypotenuse, but this time we're finding the cosine of 60. So adjacent to the 60-degree angles is x, and then the hypotenuse is 2x. So we'll have x over 2x, so cancel out those x's, and we get the cosine of 60 is 1/2. Now let's look at tangent. Tangent is opposite over adjacent. Okay, so let's do our 45. So pick one, doesn't matter. Okay, so opposite and adjacent are the same thing. So we'll get x over x, which is just equal to 1. How nice was that? Now pause the video and do the tangent of 30 and the tangent of 60. Okay, so the tangent of 30, let's go over here and find 30. Okay, is going to be the opposite, which is x, over the adjacent, which is x square roots of 3. So we'll have x, oops, I'm wrong one, x over x square roots of 3. Now our x's are going to cancel each other out, and we're going to get 1 over the square root of 3. Well, lo and behold, we all know we can't do that, so let's rationalize the denominator, and we'll get the square root of 3 over 3. Now the tangent of 60, since I've already messed up and written that x there, we know tangent is opposite over adjacent. Let's go to 60 degrees. Opposite is x square roots of 3, adjacent is x. So we're going to get x square roots of 3 over x. Well, the x's will cancel each other out, and all we're left with is the square root of 3 over 1, which is the square root of 3. Okay, so that is your assignment on trig functions, reciprocal functions, and using those on special right triangles. All of these values that you see here, the square root of 2 over 2, 1/2, the square root of 3 over 2, all of these, all the way through. These come from your unit circle. Your unit circle is found on your haiku page. Please study and learn that unit circle because you're going to need it a lot. Okay, so any questions, make sure you email me and let me know what I can do to help.